Hypothesis testing. It's not as scary as it sounds. In this video, we are going to discuss the basics of hypothesis testing, how it's done, and we are going to use this beautiful article written over hypothesis testing on Britannica. In this video, we are just going to cover what hypothesis testing is actually and how we can do that using a real world example. But there are a few other things that are not possible to cover in detail in this video that we will cover in the next and the last video of the Easy Statistics playlist. So make sure to stick around with that, subscribe to the channel and stay tuned. Let's get this. So first of all, let's just see what hypothesis testing means. So the word hypothesis, hypothesis basically is a claim, and the objective of hypothesis testing is to draw conclusions about a population with the help of sample data. In most of the real world problems, we don't have the complete population, so we rely on the sample data and some assumptions made out of it. That's why hypothesis testing is so much important. So first up, a tentative assumption is made about the parameter or the distribution. This assumption is called the null hypothesis and it is denoted by H0. Then there's an alternative or alternate hypothesis denoted by HA of what is stated in the null hypothesis. Now the hypothesis testing procedure involves using the sample data to determine whether or not the null hypothesis can be rejected. If null hypothesis is rejected, then the conclusion is that the alternative hypothesis that we have defined is true. If it sounds confusing, let us see a small example. So let's say there's a radio station and it selects the music based upon the assumption that the average age of its listening audience is 30 years. Now, there's a little trick on how to choose between the null hypothesis and the alternate hypothesis. There's always a lot of confusion going on what should be our null hypothesis. Now, the best way that I remember is, so if you see words like current belief or in this case assumption, then that thing following those words is going to be your null hypothesis. The alternate hypothesis is going to be the opposite of that. Now let's validate that with this example. So here the radio station is saying that it has made the assumption that the average age of its listening audience is 30 years. So since the word assumption is here, that means the null hypothesis is going to be the average age of listening audience is 30 years. So here is what we are seeing. So the null hypothesis is given as H0, where nu is equal to 30. That means the average age or the mean is 30. And the alternate hypothesis is going to be just opposite of that, that the mean or the average age is not equal to 30. So since we have the sample of individuals, we are going to use those sample data and compute the sample mean age. This is going to be X bar. And based on the value X bar, we are going to determine if we can accept the null hypothesis or we need to reject it. Now, ideally, if the value of the sample mean X bar is close to 30, that's what the assumption or the null hypothesis is, that means we can accept the null hypothesis. If it's not too close to 30, then we can reject the null hypothesis and accept the alternative hypothesis. I hope this makes sense. So ideally what we want to do is we want to accept the null hypothesis when it is true and we want to reject the null hypothesis when it is false. But it's the ideal case, and ideally things are not always that ideal. So we need to keep a little bit scope for errors as well, right? There's definitely some possibility of errors. So there are two types of error that are defined here. One is the type 1 error, which corresponds to rejecting the null hypothesis when it was true, and that's type 2 error, which corresponds to accepting the null hypothesis when it was false. And type 1 error is denoted by alpha, and correspondingly type 2 error is denoted by beta. This alpha is also sometimes called the level of significance or the significance value, and this is another thing that we define while conducting a hypothesis test. The type 1 error or the level of significance that we are going to consider is commonly kept at 5% or 1%. This is the maximum allowable probability of making a type error. Now we have defined a few things. There's a final thing known as the p-value or the probability value. So the p-value is nothing but the measure or the probability of observing the test that we conduct, or observing the mean value, that X bar that we have computed up here, given that the null hypothesis was true. Let me repeat that again. So p-value is the probability of observing the test statistic given that null hypothesis is true. Now the smaller the p-value, the less likely we can see the sample results or the X bar. That means if p-value is too small, then we can reject the null hypothesis. Otherwise, the null hypothesis cannot be rejected. Now let us define in a clean way what we have learned so far, and What are the key steps to do hypothesis testing? Number one, we define the null and the alternative hypothesis. If we see the words like current belief or assumption, then that hypothesis is going to be null hypothesis. The complementary to that would be the alternative hypothesis. Second, we identify the test statistic that we are going to use for testing. Now there are a lot of test statistics, and each of them comes with a certain rules, and that's what we are going to do in the later video. So make sure you subscribe to that. Number three, we decide the criteria for rejection and retention of null hypothesis. In other words, we define the significance value or the level of significance alpha, ideally which is 0.05 or 0.01 for 5% and 1% respectively. Number four, we calculate the p-value, that is the probability of observing the results of test statistic given that null hypothesis was true, or the conditional probability. Now, based on the p-value and the level of significance, we take a decision to reject or retain the null hypothesis. If the p-value is less than alpha, then we reject the null hypothesis because the probability of observing those results given the null hypothesis was true is too low. And if p-value is more than alpha, that means we have a higher probability of observing those results given null hypothesis was true. So we cannot reject the null hypothesis, hence we accept it. Hope this was clear. In the next video, we are going to deep dive into this and see some real world examples on choosing the right test statistic for hypothesis testing, and all the things will come and make sense. I hope this was useful. Thanks for watching. My name is Rishabh, and I'll catch you guys in the next one. Bye bye.